This is Mrs. Davis. This is AP Calculus. This is lesson 7.6, the topic question number 5, AP Classroom. So it's a free response topic question, so give this a go and then come back and see how you did. Okay, so let's look this over. I can see my cylinder over here. All right, so we got a barrel. It gives us the information. It's got a diameter, so it's 2 feet, so I got to remember a radius would be half that. It's draining out of a valve that's not shown. The rate at which the height of the water in the barrel with respect to time is modeled by this decreasing rate, and they give you the dHdt, the rate the height is going down, where h is feet and t is measured in seconds, and then they give you the volume formula for a cylinder. So A says find the rate of change of the water, so that'd be dW dt, or dV dt, with respect to time when the height is 4. So that's going to be a related rate question. Then let's look at B. When the height of the water is 3 feet, is the change of the height with respect to time increasing or decreasing? So this is a rate of the rate question. Is the rate of change of the height of the water with respect to time? So the rate increasing, which means second derivative. And so it's talking about the height. So we can take dH dt and take the second derivative and see whether it's positive or negative, right? If the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. So at time, let's look at C. At time t equals 0, the height is 5 feet. Here we go. Use separation of variables to find an expression for h in terms of t. So we were never given the original h of t formula for the height of the water, and this is going to help us. We can now use separation of variables for that differential equation and get a equation for the height in relationship to t. All right, so let's just get started. First one is a straight out related rate. So we know that V equals pi r squared h. We are given, don't break down now and not use your good techniques for this. We were given that dH dt is equal to negative 1/10 square root of h, and then that would be in, let's get that rate, feet per second. And we want to find the rate of change of the volume. We want dV dt when h equals 4. All right, so we know we're going to use that formula, and we know that dr dt is not changing because the radius is going to be the same. So let's see what happens when we when we take the derivative, remember we draw a line, of v. So dv dt is equal to 2 pi r dr dt h plus pi r squared dH dt. Now, this is what I was saying. We know dr dt is 0 because the rate with which the radius is changing is 0. So we know this first part is 0. So 0 plus pi r squared dH dt. So we can just substitute now. It's equal to pi, and the radius is, let's see. Do we know what the radius is? It's 1. And dH dt is, so that's like 1 squared, negative 1/10 the square root of h, which is 4. So we get pi times negative 2/10, so negative 1/5 pi. So the answer is dV dt is equal to negative 1/5 pi, and we want the rate of change of the volume, so that would be feet cubed per second. All right, so there we go, part 1, or A. B, this should be when the height is water is 3 feet. Is the rate of change of the height of the water increasing or decreasing? So the rate increasing. So we go and we need the second derivative. So we have dH dt is equal to negative 1/10 h to the 1/2. So d2h over dt2 is, take the derivative, negative 1/10 h to the negative 1/2, right? Right? And let's see, times, do I have to do 1h times 1/2, right? So, we end up getting 1/20th over square root of, over square root of h is, and is that positive or negative? This is not negative, so this is still negative. That just means it's on the bottom. So I have negative 1 over 20 square root of h. Negative 1 over square root of 20 h. And then don't forget we should have done this dH dt. dH dt. All right, and so, all right, let's see. dH dt, when the water is 3 feet, let's figure that out. So when h equals 3, dH dt is equal to negative 1/10 and the square root of 3. All right, so this would be equal to negative 1 over, when h equals 3, we have 1 over 20 square root of 3 times negative 1/10 square root of 3. So these square root of 3's go away, and I have 1 over 200. 1 over 200, and I am saying, it says it's increasing or decreasing. So that's positive. It's greater than 0. Let's just say that so we get it all worked out. Greater than 0. And so let's say because dH2 is greater than 0 when h equals 3, the rate of change of the height of the water with respect to time is increasing. So, because the second derivative is greater than 0 when h is 3, the rate of change of the height of respect on time is increasing. All right. So, let's see. At time t equals 0, the height of the water is 5 feet. So we have 0, 5. Use separation of variables to find an expression for h in terms of t. So this is actually wanting us to find c also, which again is in the next lesson. All right. So, not hard. Let's go right to it. We have dH dt is equal to negative square root of h over 10. Is that right? So let's just say dH dt is negative 1/10 h to the 1/2. Okay, so separate. So we have dH is equal to the integral of negative 1/10 h to the 1/2 dt. Did I do that right? I don't think I did that right, because h should be on the other side, because h goes with this. So let's go back. Okay, so 1 over the square root of h, dH dt is equal to negative 1/10 dt. Oh, dH. There we go, finally. Okay? Okay, so, let's go with h to the negative 1/2. So h to the negative 1/2 dh integral is equal to the integral of negative 1/10 dt. So I would have, let's see, that would be negative 1/2 h to the hang on a minute. I'm going to be adding 1, so that would give me h to the 1/2 over 1/2, so that's 2h to the 1/2 is equal to negative 1/10 t plus c. There we go. So let's see. If I want to multiply that 2 over there, I get h to the 1/2 is negative 1/5 t plus c. Okay, so now I can put in at 0, 5. So here's where I'm starting to do the work that's for tomorrow. So I have the square root of 5 is equal to, okay, wait. If I were to divide, I did this wrong. Gosh, getting tired, messing up. Okay, I'm dividing. So h to the 1/2 is equal to, I'm dividing by 2, so negative 1 over 20 t plus c. Better. Okay, so the square root of 5, let's put this, though, at 0, 5. The square root of 5 is equal to negative 1 over 20 times 0 plus c. So c is equal to the square root of 5. Okay, so that means we come back here and we have the square root of h is equal to negative 1 over 20t plus the square root of 5. And so if I'm going to take h would be negative 1 over 20t plus the square root of 5 squared. And that's the right answer. Negative 1 over 20t plus the square root of 5 squared. So that was free response number 5 for 7-6.